Welcome to a quick rundown of adaptive retraction. So what is it? It is a software desktop application for editing G-code script files used for 3D printing, specifically FDM printing. And what it does is it increases the retraction distance based off the travel distance of the extruder head. I'm going to go into detail on why I think this is important and necessary. If you're not interested in that and simply interested in how the software works, go ahead and click the link in the description. So, the way retraction currently works is by finding a sweet spot. Essentially, you dial in a single value, and if you've reduced the pressure on the plastic by retraction, the idea is that that's about all you can do. And that should be enough to stop ooze. And basically, the convention going around the internet is that there is no suction whatsoever. All you do when you retract is reduce pressure in the nozzle. In my experience, this is not the case. Through observation, I found that ooze is basically inevitable. And I have also found that increasing the retraction distance, at least up to a certain point, about 4 to 6 millimeters, will increase time until ooze. In other words, it will improve your conditions and your extruder head will be able to travel farther before it starts oozing. It will still ooze, however. So then the question is not if your nozzle is going to ooze, but when and how we can fight it. Now, like I said, the retraction distance increase does seem to help here. The reason I think it does this is because of the cohesive forces of the molecules in the plastic. Essentially, when you pull the cold plastic or the partially melted plastic up during a retraction, the bonds between the plastic means that it'll also pull up some of the heated plastic in the nozzle with it. And the farther you pull this plastic up, the longer until ooze, the greater the time until ooze. Now, I cannot say for certain whether this is the reason why increasing retraction distance helps, but I can say certainly through observation that it does help. So, that's basically the gist of it. And the idea here is that by having longer retraction distances for longer travel moves, we can still stop ooze for those travel moves. But by having short retraction distances for short travel moves, we A, save a lot of time, and B, we avoid the problems of the plastic continually being retracted over and over again for repetitive small travel moves, which leads to all kinds of other issues, grinding of the filament and under extrusion. Of course, we don't want that. So, with that out of the way, let's look at our plot here. This is basically what's going to tell us what we're going to get when we punch all these values in. You can see here, this is logarithmic down here. This is linear. We have a very non-linear curve here. Again, through my observations, I found that ooze was very non-linear with time. So I had to make a function that could encompass that, but still be robust enough that I could adjust it for different filaments because, of course, the type of filament you use is ultimately going to be very important in determining what settings you're going to need and how much ooze you're going to have to deal with. So you can see here that if you put your mouse over it, this is all part of Matplotlib's library. You can get your X and Y values, which is good. Generally, I like to look at the smaller retraction distances, travel moves, and look at the retraction distance here. That gives me a good idea of the retraction distance at those travel moves. And then, of course, up here, you can see that the Y value, the retraction distance, is significantly greater. So, how do we set this? Well, first, you pick your max retraction distance. This is going to be the same retraction distance that you picked in Cura. If it's not the same, it won't work. Other than that, it's pretty simple. once you have it set, you don't need to worry about it. Next, we'll go on to horizontal and curve steepness. So these two, it doesn't really matter which one you do first. Curve steepness, basically what you'd expect. You get a more abrupt curve, and horizontal shift will help you decide when this abrupt curve happens, or whatever curve you like. Now, of course, you can see here that the initial values do shift, and that is where the next value comes in, lower retract stretch. Now, this is a little tedious. I'm going to eventually combine this lower retract stretch with these other two values in the future so that it'll automatically be adjusted. That's just something I'll have to do in the back end. For now, though, this works. This is mostly, for personal use. So anyway, we've got our lower retract stretch. So what we're going to do is once we have our steepness that we want and our shift that we want, we simply adjust the lower retract stretch so that our shortest travel distance gives the retraction distance that we'd expect. So let's increase the values here to make our initial value a little zanier. Okay. So now at 1 millimeter of travel move, we get 1.5 millimeters of retraction distance. That's a little high. So to fix that, we'll just, and these are very small values that you need to put in here. You can just simply put in smaller values until you find where you need to be. So about negative 0.8, okay, 0.6. Let's try negative 1. Yeah, 0.6, negative 1.2. Again, a little tedious, but this will be fixed in a future patch. The reason I haven't really addressed it is because I rather make this into a Kira plugin where it is integrated with Kira, because that simplifies a lot of things. I can imagine most people don't want to download an executable application. Additionally, there's also on my GitHub a Kira post-processing version of this app. Now, this works directly with Kira. The only difference is that you don't have the plot. So you would still need the application to see the plot, but once you set your values in Kira, it's a set it and forget it thing, and it's all automatically done for you. Again, I do plan on making this part of a plugin eventually, which will be a bit more robust. Okay, let's go on to our configuration settings. So you've got what you want dialed in for your plastic. Simply go to File, Save Configuration, and you can save this configuration anywhere you want. You can also set it as the default configuration. Now when you do this, that means that every time you open up the application, this will be what is opened by default. Of course, you can load another configuration, save that as your default, whatever you prefer. This is mostly a set it or forget it approach. Just make sure that your default configuration is in the same folder path as the application. The other files can be anywhere you like. And of course, we've got the help menu here. Be sure that you do read this. It does have more information on what you need to set. It's all pretty trivial. None of it will have any significant effects on your print quality. And of course, if you need more information, you can check that out. Or email me. And let's do an example G-code. So, it's pretty easy. Just open G-code file. Here's our example G-code. All right. It's there. Just convert G-code file after that. And that's it. And it's fairly quick. This is actually a really big file. I think it's about 1 million lines of code, so it's pretty quick. We'll go to it. Takes longer to load the notepad than it does the application. Okay, so this is our first retraction move. This is still at 4 millimeters because it's a pretty long travel distance. Normally, of course, all of these values would be 4, but now you can see for smaller moves, okay, that's slightly smaller. Let's find a better example here. For smaller travel moves, here you go. You've got 0.27 millimeters. And of course, this continues on for the rest of the script. All your values will now be adjusted accordingly. And that's it. You can use your G-code file just like you normally would. And again, if you use the plugin available on my GitHub, then this is all done in Cura for you. You just need to make your G-code files in Cura like you normally would, and they will be updated accordingly. So, I hope this was helpful and that you find some use with this application. If you have any questions, of course, feel free to email me. Thanks for watching.